derivatives of logarithmic function. You have made it to this far, so at this point you're supposed to know how to take derivative using simple power rule. You need to know the product rule, the chain rule, the derivative of trig function, the derivative of inverse trig function, and also most importantly, you are very familiar with the chain rule. So in this section, I am going to add 3 more differentiation formula to your hard drive. So the first one is, look at the red box. The first one is derivative of common logarithm, log base b of x. So that is 1 divided by x times ln b. And then we have the derivative of ln x. We will be using this all the time, is equals to 1 over x. And then we have the derivative of ln absolute value of x equals to 1 divided by x. Why do we have to pay attention to that? Do you still remember the graph of ln? The graph of ln x. So what is the domain of ln x? Ln is natural logarithm. Log is common logarithm. So what is the domain of this ln x? The domain is x greater than 0. All right, x must be positive. So that's why we use an absolute value. Ln 0 is undefined. Look at the graph. Ln 0 is a vertical asymptote. And then also ln negative is undefined. All right, so let's go ahead and take a look at the first one. So the first one, we have a, we have the function is equals to log base 10, 1 plus cosine x. So if this is your first time visiting my video, the formula, every time I give a formula out, I suggest you to write it down or you take a screenshot of that, because we don't have to keep going back to the beginning of the video to check out the formulas. So this one, we will be using the common logarithm. All right, we have this. So what is f prime of x? F prime of x, according to the derivative of log, we have 1 divided by, is that x? Nope. X is now 1 plus cosine x, right? So now is 1 plus cosine x is no longer x itself, and then ln the base. So that will be natural log ln base. You don't need to evaluate what ln 10 is. And then by what rule? By chain rule, because there is a 1 plus cosine inside the common log function. So using chain rule, we have to multiply the derivative of what? The derivative of the function inside parentheses. So the derivative of 1 is 0. The derivative of cosine is, take a look, the derivative of cosine is negative sine, right? So we are going to add a negative sine x. So this one, we just use a chain rule. So f prime of x, so we put that on top. So that will be a minus sine x or negative sine x divided by 1 plus cosine x times ln 10. It is not necessary to evaluate ln 10. All right, so that will be the first one. The second one is we have ln of x. So let's do the next one right here. The next one is b. We have f of x that equals to ln x squared times sine of x. All right, so this one is one function times another function. Therefore, we have to apply product rule. So in my video, every time I mention product rule, I will tell you what product rule is, although you are responsible for memorizing what product rule is. So that is fg prime plus gf prime. And then let's do the derivative. So fg prime, so that will be ln x squared, right? We don't touch the f. The derivative of sine is, take a look for me, cosine. And then plus, that is the product rule, g, we just copy g again. The derivative of ln x squared, we have a ln inside a square function. So we bring the square down first, right? So this is still ln x, and then 2 minus 1 is first power. And then we multiply what? The derivative of ln using what rule? Using chain rule. What's the derivative of ln? I just gave you the formula. The derivative of ln is 1 over x. You will be using this over and over again in differential calculus and integral calculus, which is your next class, your next level. All right, derivative is finished. Let's put everything together. So f prime of x, that is equals to ln x squared cosine x, and then plus we have an x in the denominator, so we have 2 ln x times sine of x. The job is done. And then C we have f of x equals to ln, a fraction bar, and then we have 2x plus 1 to the fifth divided by the square root of x squared plus 1. So most people will say, well, let's take the derivative of ln using chain rule, and then using the chain, I can take care quotient rule. Is that really necessary? The answer is no. Do you still remember this from your algebra class? You have ln a divided by b. That is equals to ln a minus ln b. You learned this in algebra. So let's rewrite the function. I am not taking the derivative right now. I am rewriting the function. So you have f of x equals to ln 2x plus 1 raised to the fifth, and then minus ln x squared plus 1. The square root is 1/2 power. Alright? Do you also remember there's ln a raised to the nth power? That is n times ln of a. Remember that? The purpose of learning the ln is I want to bring the power down. Remember this? So this one we bring the power down. So f of x, so that is 5 times ln 2x plus 1, and then minus 1/2 ln x squared plus 1. That's it. There is in no way to simplify this function any further, right? No way. Now we are ready to take derivative. So derivative f prime of x, the phi is just a constant, right? So we can ignore the phi. So phi, the derivative of ln is 1 divided by the stuff inside the ln parenthesis, which is 2x plus 1. And then you have to multiply what? You have to multiply the derivative of 2x plus 1 by what rule? By chain rule. So I will just write out the derivative for you. So that is 2x plus 1. And then this one is using a chain rule. And then minus 1/2, the derivative of ln, you have to 1 over the entire thing. So which is x squared plus 1. And then by chain rule, you take the derivative of x squared plus 1. So now take the derivative, simplify everything. So you have f prime of x. The derivative of 2x plus 1 is 2. 2 times 5 is 10. 10 divided by 2x plus 1. And then minus the derivative of x squared plus 1 is 2x, right? So this thing, the derivative is 2x. And then you got a 2 right there. You got a 2 right there. So they got cancelled. So you only have x divided by x squared plus 1. So that is your final answer. All right, so far so good. Moving on to part D. So in part D, we have f of x equals to 2 raised to the x times log base 20 of x. So this one is one function times another function. I am going to write down the product rule for you. fg prime plus gf prime. So that is the product rule. And then we have an exponential function and a log function, right? So the derivative of b raised to the x, that is equals to b raised to the x times ln b. And then the derivative of log base bx, the derivative is 1 divided by x times ln b. You don't have to go back to the beginning of the video. I got the formula written right there for you. So this one, we have f prime of x. So we start the derivative. fg prime, we copy f. And then the derivative of that log is 1 divided by. Is this a 20 or a 30? I believe that that is a 30, right? Yep, that is a 30, not a 20. So that is a 30. So that will be x times ln of 30. And then plus gf prime, so copy g, and then the derivative of 2 raised to the x is 2 raised to the x times ln 2. Do not evaluate ln 30 and ln 2. Okay, this problem is not about evaluating a natural logarithm. So you have 2 raised to the x and then x times ln 30, and then plus, you just multiply them, right? 2x ln 2 times log base 30 of x. So that is your answer. So the next one is part E. Let's switch color for that. So part E, we have f of x equals to tangent of ln ax plus b. So the reason I like f of x so much, I don't really like using a y, because if you're using f of x, I know x is an independent variable. In the meantime, a and b, they are just a constant value. So first of all, the derivative of tangent x, this you will be using this again and again in your differential calculus class and your next level. That is equals to secant square x, and then the derivative of ln x is 1 divided by x. These two formula, you will make friends with them for a while. So f prime, the derivative of tangent is secant, right? So you have secant square, whatever inside the square bracket, ln ax plus b, and then you have an ln function inside a tangent, so you have to apply the chain rule by taking the derivative of ln, right? So let's just set up the notation. The derivative of ln ax plus b. All right, f prime of x equals to secant square, and then ln ax plus b, and then the derivative of ln is 1 divided by that. Do we still need a chain? Of course, you have a linear function inside a natural log function. So the derivative of ax plus b is a. So we are not going to bother to write another chain rule since the derivative is so easy. I'll just write out and then specify this is using a chain rule. And then the derivative is done. All you need to do is put everything back together. So f prime of x, that is you have a ax plus b in the denominator, and then you have an a on top, and then secant square ln ax plus b. I don't need to remind you that the a on top and bottom cannot be cancelled, right? This is our final answer. All right, moving on to the next problem. So the next problem, we have, let's use the other way. Part F, we have f of x equals to ln x e negative 2x. Can we just do the derivative right now? Yes, you can, but I want to make the work easier. I am going to apply this property, ln a times b. This one is called the product property of logarithm. Product rule is not derivative. Product rule of common logarithm. That is equals to ln a plus ln b. So this one I can split it up into two ln's. So ln x plus ln e to the negative 2x. And then you have a power rule of ln. Let's say a, you raise that to the nth power. You can bring the n down in front of the ln. And then you also have ln e that is equals to 1. And then this one you don't need that in this problem. ln 1 is equals to 0. Stuff you learned in the past. All right, so we have f of x. I am not taking the derivative right now, so that is f of x. And then I'm going to bring the 2x down, so plus negative 2x. And then ln e is equals to 1, right? So here is something that I like a lot. ln e, I will just put a parenthesis in there and then draw this, that is equals to 1. So I'm not going to worry about ln e. Now we take derivative. Look how easy that is. F prime of x, that is 1 divided by x, and then minus 2. Done. No quotient rule, nothing is complicated. We are going to, simplify the function using the stuff we learned in the past, and then we can just take one quick action in the derivative to get straight to the final answer. So that is part F, and then moving on to part G. Part G has more steps to work on. So part G, so F, and then we have G, y is equals to ln 1 plus ln x. This one I said that also find the second derivative for me. So let's find the first derivative. Okay, this one, ln A plus B. Can we simplify this? Can we? You may say, well, is that ln A plus ln B? No, this one cannot be simplified. Every time you see ln one quantity plus another quantity, don't even think about simplifying this. No way. So this, you have to just take the derivative. That's why I picked this problem. So y prime, the derivative of ln is 1 divided by the entire thing inside the parenthesis, which is 1 plus ln x. So since we have a 1 plus ln inside of another function, that means you have to use chain rule, 1 plus ln x. And then what's the derivative of 1 plus ln x? 1 plus ln x is 0, right? 0 plus 1 divided by x. So we have 0, or 1 divided by x, and then multiply 1 plus ln x. And then this one is just 1 divided by 1 plus ln x. And then you have the whole thing times this x, right? So this x just went there. In case you don't remember, you don't understand this, what about 1 half divided by 3? What is that equals to? That is 1 divided by 3 and then times 2, right? All right. So that is my y prime, and then my y double prime, I have to use the quotient rule. So what's the quotient rule? The quotient rule is gf prime minus fg prime divided by g squared. Yes, I am nice. I remind you this every single time. So y double prime, that's why you have to give me a like and then subscribe to my channel. Okay, we square the denominator first. So we have x times 1 plus ln x, and then immediately we square these things because we are following the quotient rule. And then gf prime, we copy function g right now. So function g is the whole denominator, x times 1 plus ln x. And then the derivative of the top, the derivative of 1 is equals to 0. And then we have a minus because we are doing quotient rule. And then we have fg prime. So f is 1. The derivative of that is what? This is x times another function, right? I don't recommend you to distribute the x because even though you distribute the x, you have x times ln x, that is still another product rule. So I will just go ahead, be honest, and apply the product rule. The product rule is fg prime plus gf prime. All right, so we are doing a product rule right now. So the first one is x times the derivative of the parenthesis is 0 plus 1 over x, right? And then plus, you copy the parenthesis. The derivative of f is 1. And then you clean that up. Y double prime. Okay, you have 0 times this is equals to 0. And then all you have to do is you distribute the minus, right? So overall, we have minus 1. All right, because x times 1 over x is 1, we have minus 1, and then minus 1, and then minus 1 times ln x is still ln x. And then we square the denominator, or you can put that as this, 1 plus ln x squared. They both share the square. And then negative 1 minus 1, that will be a negative 2. So you have a negative 2 minus ln x divided by x squared plus, not x squared plus, x squared times 1 plus ln x squared. All right, so that's the second derivative. And then this is the first derivative. So first and second. So that will be all in this part. In the next part, I will have more example problems for you. I see you there.